Today we're going to talk about solving systems of equations by graphing. So a system of linear equations consists of two or more linear equations with the same variables. So an example would be 2x minus 3y equals 10 and y equals 4x plus 7. So by the end of this unit, we're going to learn 3 different ways to potentially solve a system like this. But today we're going to just talk about graphing. So when we're graphing two linear functions, there's 3 different ways that our lines could look, and therefore giving us 3 different types of solutions. So the most common that we're going to see is one solution. So in order to get one solution, I'm going to start with the graph. Our graph would maybe look like this. Okay, so those lines are intersecting. So when two lines cross each other, they're going to have one solution, and the one solution is wherever they do cross each other. So that point right there, that would be the actual solution to that system. So now if we think about what the equation actually looks like in terms of the slopes and y-intercept, would the slopes be the same? Would they be different? Would the y-intercept be the same or different? So the slopes for this would be different because the lines are going in different directions. They could both be positive or both be negative, so they don't have to be opposite of each other, but they are definitely going to be different. Okay, in terms of the y-intercept, these are also going to be different. There is one exception, and that is if the actual point of intersection is on the y-axis. So if they cross at their y-intercept, then they're going to end up with the same y-intercept. For the classification, this is going to be new vocabulary. The classification for this one is consistent. Consistent meaning that it has a solution. And because it only has one solution, it's classified as independent. And I always remember that it kind of stands on its own, it's by itself, it's independent, it's one solution. Okay, so if we think about where lines cross each other, that's the solution. So how would a graph have no solution? Well, the lines would never cross each other. So they would be what we call parallel lines and look like this. So these lines are parallel. So if we think about the equation and what the slope and the y-intercept would look like, if lines are parallel, then they're going up at the same rate of change. So the slopes are going to be exactly the same every single time. For the y-intercept, these are always going to be different. Okay, and then for the classification, there are no solutions. So if consistent means that it has solutions, no solutions would be classified as inconsistent. All right, so our third example, what possibly could this be? We've got lines crossing each other. At one point, that's one solution. We have lines that never cross each other. Those would be parallel. So the third example would be if we had infinitely many solutions, meaning that they crossed each other infinite times, means that they're the exact same line. So if you had two lines that were right on top of each other, that would mean infinitely many solutions. And those lines, you can say that they're the same line. Those are also called coinciding lines. So if lines are coinciding, they are the exact same line. So for these, obviously the slopes are going to be the same and the y-intercepts will be the same because they're the same line. So this is going to be consistent for the classification since it does have solutions. And then instead of independent, this one is classified as dependent. All right, so we're going to solve this system by graphing. Very conveniently, these are both already in y equals mx plus b. So if we remember, m is the slope and b is the y-intercept. So 3 is going to be my slope and -2 is going to be my y-intercept. So when we're graphing, we always start on the y-axis. So we're going to start at -2. This is my y-axis. And then if my slope is +3, I'm going to rise 1, 2, 3, and then over 1. And then rise 1, 2, 3, over 1. And I'm going to try to graph as many points as I can because where these two lines cross each other is going to be the solution. So the more points that you can get onto your graph, the better. So now I'm going to go down 1, 2, 3 over 1. Remember, you can go in either direction as long as your line stays positive. All right, so the first line would look like this. Oh, that was a little bit off. All right, so now for my second line, y equals negative x minus 6. So this is going to be my slope at negative 1, and then my y-intercept is going to be at negative 6. So we're going to start with our y-intercept at negative 6, and then be careful, it's a negative slope, so I'm going to go up one and then to the left one. You can see this is where those lines cross each other, so we've already got our solution. But I'm going to do some more points, and we can go down one and to the right one. And so my line will look like this. Okay, so my solution is where they cross each other, which was at negative 1, negative 5. And so then because I have one solution, the classification would be consistent, independent. So in this example, to solve the system by graphing, notice our first equation is not in slope-intercept form. Okay, so to graph it, you have two choices. We could just find the x and the y-intercepts, plot those 2 points, connect them, and that's my line, and then do the same for the second line. The only downside to that is that if you're not using a straight edge or you're not careful, your lines are not going to intersect at a perfect point. So if you manipulate this equation and change it into slope-intercept, then you're going to get more points on your graph and be able to see where they cross each other. So I'm going to change both of these into slope-intercept, especially since I'm not using a ruler. But again, you can do it either way on yours. So I'm going to move the 5x to the right. So we get 2y equals negative 5x plus 20. And then we're going to divide everything by 2. So we get y equals negative 5 over 2x plus 10. Okay, so now we can go ahead and graph that. We're going to start at 10 because that's my y-intercept. And then my slope is negative 5 over 2. So we're going to go down 1, 2, 3, 4, 5. And then it's negative. So since I went down, I'm going to go to the right 2. Then down 5, right 2. Down 5, right 2. And then we can get one more point. Down 5, right 2. And then my line would look like that. Okay, for our second equation, negative 10x minus 4y equals negative 40. So I'm going to move the 10x to the right. And again, I'm changing it into slope-intercept. So we get positive 10x minus 40. Be careful with your signs on this one. And now I'm dividing everything by a negative 4. So we get y equals, and for my slope here, it's still going to be a fraction, but we want to simplify it. So we get negative 5 over 2x, and then plus 10. So notice if we're comparing these two, they're exactly the same. So we don't need to graph this second one. This line would have been directly on top of that first line. So that means that for our solution, we have infinitely many. And that means for the classification, this would be consistent because it does have solutions, but it would be dependent. All right, next example, we're going to solve again by graphing. On this one, our first equation is in standard form, but our second equation is already in slope-intercept form. So I'm going to start out by taking the first equation and turning it into slope-intercept. Now on this one, had we wanted to find the x and the y-intercepts, it wouldn't work because 16 is not divisible by 3. So you've got to make sure if you want to find the x and y-intercepts that it is divisible by both coefficients. So on this one, we have to change it into slope-intercept. So we get negative 3x plus 16, and then divide everything by negative 4. So y equals, this is going to become a positive 3/4 since it's a negative divided by a negative, and then this will become minus 4. So we can go ahead and graph that. We're going to start at negative 4, which is our y-intercept, and then go up 1, 2, 3, and to the right 4 since this has a positive slope. 1, 2, 3, and then to the right 4. And then we'll go down 1, 2, 3, and to the left 4. All right, and then connect those points to make our line. And then the second equation, we can just go ahead and graph. This one starts at positive 5, and if we notice, we have the exact same slope. So if we have the same slope, that means that we have the same rate of change. Oops, I went one too far there. So this is up 3 over 4, up 1, 2, 3 over 4. Then I'm just going to graph one more on the other side, down 1, 2, 3 over 4. So if we have the same slope, that means that these are going to be parallel and never cross each other. So for the solutions, that means we would have none. And if there are no solutions, then that would be classified as inconsistent. So some more examples. The first example, we're going to decide if negative 2, 6 is a solution to the system. So what's great about systems is that we can actually check our answer. So on the previous examples that we did, when you have an actual solution, you can check it very easily because we know that this is telling us that negative 2 is x and 6 is my y value. And so I can take those and I can plug them into this system to make sure that they work. Okay, so if I plug in negative 2, I would have 4 times negative 2 plus 3 times my y value, which is 6, and I want to check to see if that equals 10. If it does work, you have to make sure that you also check the second equation. If it doesn't work, then we're not going to have to check the second equation at all. So we get negative 8 plus 18 equals 10, which is true. 10 equals 10. Okay, so now I can check my second equation, y minus 2x, so that's going to be 6 minus 2 times x is negative 2. Does that equal 2? So this would be 6, and then here we've got to be careful because this is a negative 2 times negative 2, which will become plus 4 equals 2, and so we get 10 is equal to 2, which is not true. So this is not a solution. And for the explanation, this is your explanation. So showing that math that you plugged it into both of them and it doesn't work is proving that it's not a solution. So for example 2, it wants you to create a system of equations with no solutions, okay, and then justify your response. So no solutions means that the lines are parallel. So you could come up with infinite different answers here. What we know about parallel lines is that they have the same slope, but they have different y-intercepts. So I can write two things in y equals mx plus b. Let's say my slope is 1/2 x. I can make this whatever I want, minus 7. And then the second equation, as long as I have the same slope and I have a different y-intercept, then this system would have no solutions.